we are working on triple integrals, and one of the hardest parts to setting up a triple integral is getting the limits of integration. So in this question, you're being asked to do this guy, and here is essentially the list of restrictions that define the region, right? So this is a 3D region, and I've got this expression. I've got x equals 0, I've got y equals 3x, I have a z equals 0, and we're trying to put these together in a kind of sensible order. So first thing that strikes me is that I've got z equals 0. Now, if I rearrange this equation here, then you can say that z is 9 take away y squared. And then if you move one stage back, you can then say that. Now, typically when you take a square root of both sides, you're going to do a plus and a minus. But in this case, they told me one other piece of information, and that is that the whole region is in the first octant. There we go. And the first octant is this region in here. That basically means everybody is positive. So y is also positive, right? So I know that z goes from the floor to this guy. So I'm going to go, what color am I going? Blue. Z equals the floor, which is 0. And z is going to be the square root of 9 minus y squared. Right. So once you've decided what the z does, then you really want to collapse this shape down into the first quadrant and see what other restrictions that you can now work with. Okay, so let's work on this guy, right? And this guy. Well, y equals 3x is good. And if you think about what you can then get, well, if you make z 0, what you're getting is y squared equals 9. And that tells me plus or minus 3, but since it's positive, it gives me 3. So I can now say that I'm going to go from y equals, and I'm going to do 3x to 3. And then I'm going to do x goes from 0 to x equals 1. If you want to say, well, basically that's it. Now, why have I got x equals 0 to x equals 1? Well, I've got something in here with 0, which is, well, because you tell me. And now I need to figure out y to get 1. And if y is equal to 3x, and that's 3, then 3 times 1 tells me x is 1. So that's why I got the 1. Once you have set up that integral, it's then just a triple integral, and off you go. Now, that might not be the only order that you could do that, but that's the order that I've got in front of me here, so I'm using it.
Professor, I had a question.
Yes.
How do you decide which, for the
1, 2,
y,
3.
yeah, which 3 goes first, or which 3 goes on the bottom and the top of the integral?
Right. There is a little bit of who goes first. Oh, it sounds like that joke, who goes first. So let me write them down again because I've got so many bubbles around. I got this guy. And then I've got this guy, right? Not worrying about any of the other ones right now. So when I look at this guy and then I look at this guy, what that tells me is Z can do Ys and Ys can do X's. So that's how I decided to go Z, Y, and X. Right, you might say, well, could I do X to Y to Z? Yes, I could have. But if you'd say, let's say I say, I'm going to use Z, right? Well, if I do Z, isn't Z going to be in terms of Y? And since Z is going to be in terms of Y, doesn't that make Y have to be in the middle? Right, one leads to the other. Now, once I get y's, won't y's be in terms of x? Oh, that's okay, because y's needs to be in terms of x, so that isn't going to break any rules, right? But if they had done something like these two guys, just making this up, but in this kind of world here, couldn't y get you z's and z's gets you y, right? I could decide which one I want to do, and it wouldn't really make a lot of difference. But it would make a difference if I told you that, wouldn't it? Because you know you need to finish with numbers. So you kind of have to, it's not a, what's the word I'm looking for? It's not obvious what you to do. It's a kind of, you look for patterns and you kind of say, all right, I know I'm going to finish with numbers. Which one of the three variables would be okay, right? What I can't have is I end up with an x equals y here, right? Isn't that going to break the rules? So you try a permutation and say, all right, if z gets me y and y gets me x, is that going to work? Yeah, not a problem. But if I do it and I say, okay, z gets me x's, x gets me y's, but y's get me z again. Oh God, that's not going to work, because I'm not going to, I'm going to get a little cycle and get out of nowhere. I tend to, as a general rule, try and start with z's. Because very often, if you can start with z's, you can just drop the picture down onto the xy plane and it becomes a double integral that we're much more comfortable with. Right. So if I drop this down into the floor, this guy here, right? If we make z 0, what do I get? I get y squared equals 9, right? If I write down what the other guys are now, so what do we know? We know x equals 0. We know that y equals 3x, right? And I've already made z 0, right? So I've committed to the z's. Can you see here, what does this tell me? This tells me y could be 3 or minus 3, but it doesn't really tell me y is 3. And I could draw a straight line, y equals 3x, right? And then I would put in y equals 3, which is here, and there's my triangle. And then I could do my operation. I've lost people. Where's everybody gone? I don't have anybody. Oh God. For a minute, everybody disappeared and I thought I was talking to myself. So if I go back to this one, y squared is 9 now. Why? Because I've made z 0, right? I've dropped to the floor. And that becomes only 3. So I got this guy. And x equals 0 is this line. And y equals 3 is that line. Now, if you do that as a range, can you see the x goes from 0 to that number there, which is 1, which gave me this, and y goes from this guy here, 3x, to here is 3. Do you see it kind of makes sense now? Does that help a little bit?
Yeah, that helped a lot. Thank you.
Okay, so try and do the z's first. How about that as a good rule? And then only if that's not going to work do we start making life hard and see if there's another permutation. At this point here, can I leave this guy and say, look, it's just a matter of integrating, plugging things in, integrating, plugging things in, integrating. It takes 10 minutes. I'd rather not do it if I needed to. Are we good? Right. So the next one, again, I'm focusing on setting up the triple integral. The guy that we're going to be setting up here is a triple integral of the number 1. And they're telling me in the question to do it in the order dz, dy, dx. That's really nice that they do that. If the function that you have here is 1, what you're essentially finding then when you do a triple integral is a triple integral of 1 is the volume of that region E, you know, the triple, right? If you do a double integral of 1, isn't that the area of D, right? So back to the question here. We are looking for a tetrahedron enclosed by the coordinate plane. So they tell us 7x plus y plus z is 4. And I'm going to have to sketch this thing to see what they're talking about. If you make these two guys 0, it crosses the z-axis at 4. Okay, I know what's happening. And if you make everybody else 0, it crosses the y-axis at 4, and it crosses the x-axis at a rather ugly 4/7. So the tetrahedron shape they are talking about, can you kind of see it now? You see it? It's one of those little pyramid shapes, right? So I'm going to have to set up limits of integration. So the floor is definitely down here. And this shape is being built using this function. So I'm going to rearrange it as z equals 4 take away y take away 7x. Right, that would be this point here floating in space, and it finish on the floor. So z equals 0. So there is my z's. From 4 minus y take away 7x and 0. Now, once you've taken care of the z's, don't you just basically think of what the shape on the floor is, right? So imagine the shape has a shadow on the xy floor. And if I look at the shadow and I reorientate it a little bit, x is 4/7, y is 4, and this little guy here is the triangle on the floor. And this little guy is going to give me the x's and the y's, right? I think this is going to lend itself to a type 1. And the x's are going to go from 0 to 4/7. And the y's are going to go from 0 to, we've done this a few times with triangles. Don't I need to know the equation of this line? Now, I know it's negative. If I do rise, which is 4, over run, which is 4/7, I get a rather nice answer. It's -7x. And it cuts the y-axis at 4. So the equation of this line is negative the slope, -7x plus 4. Are we comfortable with the equation of the line? And that goes here. Since this is a volume, shouldn't the answer be positive? So if I get an answer at negative, then I probably get one of these two, probably the middle one, right, switched around. I'm pretty comfortable that one would work. So our integral would look something like this, 1. The z's go from 0 to 4 minus y take away 7x. In this case, isn't it obvious it has to be z because the most variables always goes first. Then we move in and we're going to do y equals 0 to y equals -7x plus 4. And then we move in and we do x equals 0 to x equals 4/7. And that is the triple integral that we spend the next 5 minutes or so evaluating. It's just going to be a polynomial, right? It's just going to have x's and y squared and whatever in it. Are we good with that question? Right? Which kind of brings me back to Tia's question. In this particular question, the minute I saw this, wasn't it kind of obvious that it's probably, do z first, that z's going to be first and it's going to be in terms of x and y. Then once I did that, I'll darn it in space. Do you know how I did all this hard work? Watch. If this hits the floor, isn't that the equation? If you rearrange that, guess what? y equals -7x add 4. I just spent a lot of work that I could have got from the equation. Do you see that? So that wasn't necessary, but the fact that I did it that way, it kind of shows you, that it worked, right? Of course, I would still need to figure out the range of x's and y, so I'd probably still draw this picture. I just wouldn't create the equation of the line because I know what it is. Do you want me to go through this horrible mess, or are you comfortable with me just saying, you go through this horrible mess? Okay, I'm moving on before you change your mind. Again, we're just going through the setup process because that takes a fair amount of time. This is question 14. We have y equals x squared. Oh, by the way, it's find the volume again. And we have z equals 0 and y plus z equals 1. And from that entire package, we are going to have to figure out, right, what the limit of integration is going to be for 1. So I'm going to try, I've only got 3 guys to work with here, so that's nice. I'm going to try and do a z guy. If I rearrange this, would you agree that z is 1 minus y? And if I keep this again, I have got a good starting point. Z equals 0 to z equals 1 minus y. Are you comfortable with that? Now, if you make z 0, I am going to rewrite all the information, but with z being 0, right? Because once you've done the z, it hits the floor, you're good to go. In this case here, that's not important, but this and this is. Because once you've made z equals 0, doesn't your shape, the shadow of it, collapse to the xy plane? And what I have here is a y equals x squared and a y equals 1. So the region that we are going to be working with is that. Are you comfortable about how we figured this out from here, right? We did z equals that to z equals 0, and that got me the limits of integration of z. I then assumed that z is no longer in the building, right? Z 0, we're now focusing on what the information looks like when z becomes 0. That becomes y equals 1 now. That doesn't matter. And that becomes y equals x squared. When you put those together, do you see the shape that you generate? I think this one lends itself to a type 1 vertical rectangle. This point here is -1, and this point here is 1. Couldn't you use Desmos if you weren't sure? So I can tell you that the x's are going to go from -1 to +1. And if you look at this rectangle, what goes on the right-hand side, where my finger is? What should go here? Top, bottom, top, bottom. What should go here?
X squared.
Okay. There's your 2 y values. Small guy on the left, big guy on the right. That top guy is him, and he's not x squared, is he?
Then 1.
Yeah. If you had done that, do you know you'll get the right answer, but it'll be -42, not +42, so you can fix it, right? But it's better to get it right if you can the first time. So we have got all the pieces. X is going to go from -1 to 1, and y is going to go from x squared up to 1. I know now I'm looking at, doesn't it kind of sound like x squared should go there and 1 should go there, because it just feels like that's right. It's not, but it feels like it's right. In this order, it's going to be a dz, a dy, and a dx. Okay, let's set this guy up then. X is -1 to x equals 1, y equals x squared to y equals 1. If you integrate that, you basically just get z evaluated at 0 and at y, 1 take away y. And now you can do those two. So it's going to be x equals -1 to x equals 1, y equals x squared to y equals 1. If you plug in this guy, you basically just get that guy, take away nothing. So I'm picking this one because it's nice. By that I mean it's relatively easy to do. Now, if you integrate this guy, you get y, take away a half y squared, evaluated from y equals x squared to y equals 1. If you plug in 1, you get 1 take away a half, subtract an x squared, take away 1/2 x to the 4. And this guy is a half. Take away an x squared plus 1/2 x to the 4. So far, so good. Right, so let's see where this leads to. 1/2 x, 1/3 x cubed plus 1/10 x to the 5, evaluated at -1 and at 1. If you plug in 1, you get a half, take away a third, plus 1/10, subtract. If you plug in -1, you get -1/2, you get plus a third, plus 1/10. A half take away -1/2 is 1. A third take away a third is -2/3. And 1/10 take away a tenth, gone. So it looks like the answer is a third. Let's see what it is. Question is this. Okay, I have a half, I have a -1/3, I have a tenth. Check. I have take away -1/2, check. Add a third. They have take away a third. So that's the only thing. Oh no, it's going to be take away. Okay, that's fine. Take away tenths. So a half take away a half is 1. I have that take away that is -1/3. 1/10. Oh, they have add a tenth here. Why is that? Oh, because -1, that is -1/10. Okay, so there we go. Almost right. And the answer ends up being 8/15. Let's check that out. 1, take away 2/3, add a fifth. Yeah, 8/15. A little hiccup at the end, but pretty good. Any questions about, well, any of the ones we've done so far? There has been a theme that you take care of the Z's first and then you drop the thing on the floor. Now, that's not going to be happening every example, but it certainly seems to be the predominant order. So I'm going to quick look at the next question where all bets are off. So this is the final one. It uses it to find a volume again. Okay, so that at least is interesting. And we are looking at a y equals x squared plus z squared. And we're looking at a y equals 32 take away x squared, take away z squared. And this one is not going to be do a z, do a y, do an x. And the reason I'm saying that is, do you see these two guys are screaming out, use me first? And I'm making an assumption, which I may get back to front, but the way they're written them, I'm assuming that's a small one and that this one here is the big one. So far, so good. Now, what's going to happen next is that we have to then take this, right, this information, we have to reduce it down into then what's going to happen. Now, if you can imagine that we have over here the XZ plane, once we've taken care of the Y's, instead of dropping it to the floor, can you imagine that we build the shape on the XZ plane? And what that is telling me then is that don't you make y equals 0, right? Because it's on that plane, the y will be 0. So if I take this information, I now have x squared plus z squared equals 0. And I have 32 take away x squared, take away z squared. Are you with me right now? I've made y equals 0. Now, I'm going to treat each one separately because you don't know what you're getting. I know what this is telling me. Isn't it telling me x is 0 and z is 0? And this guy, well, isn't he telling me that x squared plus z squared equals 32? Now, normally we do polar coordinates, don't we? We do them with x's and y's and so on, but I can actually work on this in a slightly different way. Can we imagine using the x and the z axis? Right. Now, if I used those, wouldn't x squared plus z squared equal? God, she is noisy today. Hey, young lady, you be quiet. Hey. Okay, I'll give her a talking to later. If I ever get a chance to, right? So what we have here is a circle, radius the square root of 32. Would you agree? Come on, let's go. Come on. Oh, they're weird dogs today. Right, so where was I? Yeah, right. I want to create this this shape here. I could certainly do it in terms of polar. Now, if I want to do it in terms of polar, where did that 32 come from? Oh, I know where it came from. My apologies. These two guys here are going to be intersecting each other. I didn't take that into account, but I have things going on in my brain. If you bring these over to the other side, I get x squared plus z squared is 16. So rearrange my answer to be a circle, but a circle radius 4, which means I can do theta from 0 to 2 pi, and I can do r equals 0 to 2. And so I'm just basically going to keep that as a y. And this guy is going to be an r d theta. And I've got a theta going from 0 to 2 pi. And I got a r value going from 0 to 2. So what I did instead is, instead of making that 0, I just made them equal and solved. And that actually generated that region a little bit easier. The x equals 0 and the y equals 0 wasn't actually quite as good, because now I think about it, it's actually the image isn't on the y-axis, it's the two things meeting, that thing meeting, and it's the overlap of the two that is then projected onto the y-axis. And that kind of does that. So for the last few minutes, let me show you what we have set up for you. I am not it's not easy for me. When I get distracted, I totally lose all thought processes for ages. So the reason I'm all over the place is because I'm distracted. So are you looking, I hopefully, at our math module? Right, our Canvas. Right, so what we have here, if you click on this one, is an information page that basically, I make it a little bit bigger and do that. Your exam is on Monday and it's going to take place 12 to 2. If that doesn't work for you, there's a little bit of wiggle room, but you need to contact me about when you want to start, when you want to finish, and we can, up to a point, we can be flexible about that. Oh, my E had a space in it. Here are the topics that we're going to cover. We haven't done this fella here, but we'll start that one tomorrow, probably finish it on Thursday, which gives us like Friday just to talk about the midterm. Very important that you show the working. So if you've been doing your homework questions and cutting corners and doing things like that, that's fine, because I understand, you know, you've got a lot of homework and you have to do what you can. But for the midterms, it's really important that you show me the working. Because if you get something wrong, but you do the correct process, remember that earlier question where it was a -10 and it should have been a +10. If I didn't see all those calculations because you skipped every second line, then it would be very difficult for me to understand why you got the wrong answer, because I wouldn't be able to tell where you went wrong, because there's bits missing in your writing. So you have to be, show me everything that you can. And that way I can say, -10 should be +10. That's worth a couple of points. That's it. They get the rest. What are you allowed to do? You've had me before, you know the rules, right? If it's physically written down, you can use it. So if you've got good notes, use them. Don't have too many notes, because I'm not testing your ability to look up notes and find out how to do things on the fly and then do the question. 2 hours is not enough time for you to do that anyway. You will run out of time. Notes are there for, you know, things that you don't want to memorize, you know, like the unit circle, I guess, or whatever, or formulas, you know, the formula for surface area or something, right? You might want to just have those handy. Those are the best usages of them. You cannot use any software except what I provide. So I'll be providing you with Desmos and GeoBra, because sometimes you might want to draw and see visually things. But you're not allowed to use Mathematica. You're not allowed to do online tutoring. You're not allowed to phone a friend. You're not allowed to go next door and ask your dad, right? No human contact, either electronically or physically. We want everybody to be treated fairly, and that's the only way, I think, is a reflection of what you know, not what you can find out from other people. Now, once you've done it, I have a program called Microsoft Lens, but you can use anybody you like. And you're going to upload your working to well, I'll show you in a few moments where that goes. Here is something we should emphasize. There are no extensions. Week 5 is a drop dead midnight on Sunday, because Monday is the midterm. So if you ain't got your tests done, you ain't getting it again. If you haven't done your homework, shame on you, right? You knew it was coming. You got to figure out the thing. That's it. No exceptions to the rule. Make sure that you're as prepared as you can be for Monday. Okay, any questions so far?
I have a question about that.
Mhm.
For the week 5 test, will we know our grade before the midterm?
Probably not, because it won't be due until midnight Sunday, and I won't see you until the next day. And well, I am going to be supervising a midterm, so I can check homework assignment. I can check at least tests, online tests, relatively quickly during that period. I'll try. I can't promise anything. I don't know. What I do intend to do, and I haven't got time because I'm doing preparing these, for instance, is that I will send you out a week 4 report, so at least you'll know what your grade is up to last week's. Right. Hopefully it won't change much between then and the midterm. And once you've finished the midterm, I'll have all sorts of things to do, but by the end of the week, probably Friday, I'll send you out a report on everything up to and including your midterm. So that will give you an idea how you do. So that was information page. Here, I hope is the right one. I'll tell. Yes, it is. This is the Zoom meeting. So your midterm is not your class meeting. It's this one here. We make all this a little bit bigger. Okay. This is where the midterm exam will be. I'll click on it, and it's blank, as you'd expect. On the day of the midterm, all WebAssign will disappear. So you won't be able to check anything from there. All of Canvas will disappear except this. Here is how you upload and use Microsoft Lens. Now, here is where you'll put in your working. Once you've done the working, you'll take pictures. It's all going to be in Canvas. Show you how that would work. Start assignment. Add a file. Upload file, I should say. Choose a file. Pick your file. Put it in here. And then submit. And that's it. There it is.
That where we is that also where we submit our checks?
This is where you upload your working to your test. Yes. I guess upload midterm exam working here by 2:30. Make it clear. Your test is here. You upload your working here. And there's the GeoBrand Desmos, and there's the practice one. So if I click on this guy, hopefully make it bigger. A bit bigger than that. It's just a kind of an example of, you know, similar things. Don't expect just because a question is in the practice does not mean that a similar question will be in the midterm, and just because it's not in the practice doesn't mean that it won't be, right? These are just a snapshot of what you could get and nothing else. Any questions again?
Do you accept Bitcoin?
Yes, but I will still fail you. And the reason for that is I've been told that it's not bribery if it's not quid pro quo. So you give me the money and I keep it, but don't do anything. It's not bribery. I've been told. Now, if you could afford enough to bribe me, you wouldn't need to take this exam and I wouldn't need to be teaching. So neither of us have got that kind of wealth, right? So it ain't going to happen. Right. Are we good? Any other questions? Not that Wendell would ever think of bribing me. Although I do think he's quite rich. He's just not telling anyone. Okay, if that is that, have a look around, see what's there, see what you can glean for it. Try and get as much time as you can. Be prepared for this. It's a biggie, right? Apart from the final, which is even bigger, this is going to be a big determinant on how well you do in the class. So you want to make sure that you give it the best shot that you can. And Christopher, if it really gets difficult, why don't you leave home for a fortnight, do all your work somewhere else, and then you can come back and visit your family afterwards?
Oh, I don't have that option.
Okay, you're going to put that out as an option, right? Okay. Okay, bye-bye, guys.
Bye. Oh, I did have a question on number 9 from the homework.
What section?
The same section we were just on. Sorry, let me.
Okay, not a problem. Number 9, triple integrals. Let's find yours because they keep changing the numbers here. Christian, number 9. Christian, where the heck are you, Christian?
You lost me already.
I've literally lost you. I'm not good at scanning. There we are. I found you.
There it is.
Do you know if your name is English? It sounds English.
I have no clue. I know my last name is from the city of Spain.
Oh, so it's Hispanic.
Yeah,
Right. You said question
9.
9, and we are on
15.
11, right?
Yeah. Yeah.
Okay, so I was in the wrong place. That's why that didn't make sense. It's on the more page. Let's see if we can get it this time. So, oh God, no, my brain's going. What's the section number?
15.6.
Okay, I was at the right place. And the question inside there was 11. Is that, was it?
No, the question I need is number 9.
Number 9. Okay, I found it.
Question 11 was the one everyone was having issues with in stats.
Oh, okay, that's right. Let me show you the setup for it. So there we go. So we're being asked to do a triple integral, and the function is 7xy, and we're going to figure out what combination we have. And we're looking at z equals 1 plus x plus y. And it's a region above the xy plane, and it's bounded by y equals the square root, y equals 0, and x equals 1. Now, they say above the xy plane is essentially telling me z equals 0, because xy plane is z equals 0. So I now know the z's. Z is this guy, and above the xy plane told me that guy. So let's focus on this. So on the floor then, we have y equals the square root of x, which looks like that. What axis is y equals 0?
Say that again. I'm sorry.
What axis? Is it the x or the y axis? What is y equals 0?
It should be the x-axis.
Yeah. And then finally, x equals 1. So you put that package together. Can you see That's the region that we need to now use to describe the range of x's and y's, right? It's this little corner cheese looking shape. My favorite go-to is vertical type 1. So when I can do it, I tend to use them. And what does that tell me? Well, it tells me that x is going to go from 0 to 1. And I'm just putting them in wherever I can find room. And y is going to go from top to bottom. Well, the bottom is 0 and the top is the square root of x. So when I put that whole package together, I'm looking at x going from 0 to 1. And then moving in and doing y equals 0 to the square root of x. And then I'm moving in and I'm doing z equals 0 to z equals 1 plus x plus y. And then you can do 7xy, and I don't have room, but well, maybe I could squeeze it in, dz dy dx, and that would be the integral. So did you set it up correctly?
Yes, I got all that. I think the part that killed me is the dx version at the very end.
Okay, do you, well, that the dx version at the very end comes from what this guy looks like, agreed? So
Yeah.
let me just move in then. So we're going to do it in x equals 0 to an x equals 1. I'm going to have to do this guy before I can get to the guy that you really want. And so if you take 7xy, you just basically get 7xyz evaluated at z equals 0 and at z equals 1 plus x plus y. Does that look similar to the way you approached that one?
Yes.
So we're just going to, in case there's a mistake here, because all it needs is a +1 and which should be a minus, and the answer is going to be wrong. And it might not be at the end that the problem happened. It might have happened here.
Yeah.
So here we go. You're going to get 7xy, 1 plus x plus y, take away a whole load of nothings. This expression has to be distributed. There's no advantage of leaving it in that format. So it's going to be 7xy plus 7x squared y plus 7xy squared. Is that how you tackled that?
Yes.
Okay, so what we're now going to be moving on to is this guy. Well, with respect to x, you're going to get 7 to, with respect to y, I should say, you're going to get 7 over 2 xy squared. This guy is going to get 7 over 2 x squared y squared. And this guy's going to get you 7 over 3 x y cubed. Does that look right?
Yes.
Okay, so you're well on your way to doing this correctly. So what's that going to be? It's going to be 7 over 2x. If you square the square root of x, you just get another x. And it's going to be 7 over 2x squared. And if you square that guy, you just get another x. And then the ugly one at the end is that when you take this guy and you cube him, you're going to get an x square root of x.
Yes. That is the next part that I can't seem to figure out from.
Okay, so what I need to do is tidy up these various x guys by combining them to get 7x squared, 7 over 2x cubed. And this last one's the weird one. 1, 2.5. And 2.5 is x to the 5 halves.
Yes.
Okay, then keep going. Add 1 to the power and divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, 7 halves. Dividing by 7 halves is the same as multiplying by 2/7, so that becomes 2/3. And we're going to do x equals 0 to x equals 1. That's not too bad, don't need that anymore. That's going to get me 7/6 plus 7/8 plus 2/3. Take away a whole load of nothings.
So so the 2/3 x to the 7/2. How'd you get 2/3? I got 221.
Oh, I added 1 to the power. I then divided by the new power. Well, dividing by 7/2 is the same thing as multiplying by 2/7. They cancel, and that's where the 2/3 came from.
You know, I forgot to cancel the 7 on the bottom. I times it to the 3, and that's how I kept messing up.
So it really wasn't, it's not the heavy duty math that caught you, right? It was just some fraction thing.
Yeah, that's where I
Right.
messed up.
Let me double check on it since we are here. It should be 65/24. So there's 7/6 plus 7/8 plus 2/3, and then turn everybody into fraction, and 65/24, and that's the right answer.
That would be great. Except mine was 5xy. And I did it on an example. So that was my last shot. But I understand what I did wrong. Thank you.
Okay, you're welcome.
Have a
Right,
good
any
day.
other? Yeah, did you have a chance yet, Maggie, to finish off that horrible one that you were dealing with?
I did, and I got 1 again, and I don't know
Okay,
how
so-
I'm messing it up.
What you're going to tell me is the line that we left off at, and we're going to continue from there. So do you want to read it out to me, or? Because I don't think I've got it handy anywhere.
So the line we left off at was you had the integral from 0 to pi halves of negative a square root quantity a squared minus a squared cosine squared theta. And then you had plus a square root a squared d theta.
A squared, what else?
It was a squared minus 0. Because
No,
it
I
was,
can't read that. Okay, I got this guy.
yeah,
Plus, say, what's next?
plus a times the square root of a squared minus 0. So it's just a squared.
So, that guy.
Mhm.
Okay, and d theta.
Yeah.
Okay, so let's make this look pretty. I have negative a. I'm going to pull out a squared as a common factor. I'm going to call that a squared. That's a plus, make it more obvious. This guy is a squared sine squared theta plus a squared. And sine squared and a squared inside the square root gets you a sine theta. So far, so good. I'm going to combine these two fellas together and get negative a squared sine theta plus a squared. So far, so good. What I'm going to do now is pull out an a squared. Don't need to, but I'm pulling it because it just makes my life easier. And it's going to be negative sine theta plus 1 d theta. That just cleans up the integral, so it's easy to look at. If you integrate a negative sign, what do you get?
Positive cosine.
Okay. And a 1 gets me a theta. And I'm going to evaluate it from theta equals 0 to theta equals pi upon 2. I'm going to have an a squared over here, just out the road. So it's going to be the cosine of pi upon 2 plus pi upon 2, take away the cosine of 0 plus 0. Be comfortable with that? And if you look at the cosine of pi upon 2, it is 0. So I get that guy. The cosine of 0 is 1, and I get that guy. So I now have a squared pi upon 2, take away 1, which is the answer. So where did it go wrong? Because you were good up to about here, as far as I recollect.
Yeah, I didn't separate out I dropped a 1 when I pulled out the a squared.
Oh, so you just did this guy?
So yeah,
Okay. Well, now you know.
alrighty, thank you.
You are welcome. Bye-bye for now.
You have a good one.
You too.